Hello everyone, welcome back. My name is Mr. Chai. Right now, today I'm going to walk you through another example of creating a reduction formula using integration technique. All right, now you can look through the question on the screen. Right now, here we are given an integrations of cosecant to the power n, which they denote as in. The domain restricted between 0 and pi over 2, knowing that the n is only more than or equal to 0 here. Okay. All right. Now, the first question is show that for n greater than or equal to 2, the following reduction formula is correct. All right. Let's look at how we're going to work this out. All right. Okay. Now, there are a few tips for those who are using this as an exam material. Okay. Now, first of all, if you are dealing with trigonometry, cosecant, sine, cos, or tangent, and so on and so forth, do try to recall any identity, any trigonometry identity that we can make use of or might be related in this case, right? So one of the identity that I can think of at this point would be now that would be like 1 plus cotangent square is equal to cosecant square. Right. Now that's one of the identity, okay, that you might need to use in a while. Right. Now using this identity here, we notice that it has something to do with cosecant square. And then how can we make use of this cosecant square? Now, that is the key to forming this reduction formula. Now, other than that, we also need a few results that we have or we can obtain from differentiations. Okay, now the two results are the first one being the differentiation. So I'm going to show it to you here. Now, the first one would be the differentiation of cosecant x. All right. Now, bear in mind you can use your quotient rule or chain rule and so on and so forth to deduce or to produce the differentiations for this cosecant. All right. Now, after you've done that, the result that you will get will be cosecant x cotangent x here. All right. Okay, if you are interested to work this out, you can apply the product rule or chain rule. Okay, now just for learning purpose, I'll show it to you how do I actually derive this. All right. So first of all, to differentiate this is same as differentiating sine x. Okay, now, all right. Now in this case, you can actually use the chain rule if you like, or you can apply your quotient rule. Doesn't matter in this case. Take for instance, if I apply the quotient rule, that would be 0 sine x minus a 1 cosine x divided by sine square. All right, and then if I try to simplify this, I will get negative sine, negative sine. That is negative cos x over sine square. Okay, that's what I have at this point. And then from there, you can apply divide and conquer strategy. Now you can see that we have here, and then we have another part which is sine x. All right. Now knowing that cosine over sine x is actually cotangent, and then 1 over sine x is cosecant. So that is the reason why we can obtain this result of this differentiation. So therefore we have cotangent x cosecant x here. Or you can actually write it down as cosecant x cotangent x. And then there you have it. That's the proof as to why the differentiation of cosecant would give us negative cosecant cotangent there. We are going to rely on this result shortly. Okay, so I'm going to label that as 1. Okay, so I'm going to pause here, give you some time to digest that if it has been a while you've been doing differentiation. Okay, all right. Okay, now I'm going to erase this because we're only going to make use of the result here. All right, then there you have it. That's the first result that we need. Okay, now the second result that we need will be here. We know that the differentiation of cotangent x would give us a negative cosecant square x. All right. Now the same method that I would apply here to show you how do I derive to this result here. Right. So the same thing, that is cotangent x is the same as differentiating tangent x. So the same procedure, I can apply my quotient rule. All right. Now, as a result of the as the result of the quotient rule, I would be able to reach this conclusion. So just let me take a shortcut and show it to you here. I will end up with negative secant square x over tangent square x. Right. And then, of course, you can apply a bit of algebraic approach here. Now, for me, I would be happy to do this. Okay, I know that tangent x is sine over cos, so therefore it will be the same as this. Okay, and then you can see that the result is very obvious. Now that would be our negative cosecant square x, right? So the differentiation of cotangent would yield a negative cosecant square x. Now that will be the second result that I need to rely on to produce this reduction formula. Okay, so I hope that is clear. I'm going to pause there for you to revise a bit on your differentiation. Basically, you can get this result from your data booklet, right? All right. So if you are happy with this, now we are going to get ready with the reduction formula. Okay. So these are the two results that we need to make use of, and then don't forget the I also need to show you that result if you are going to perform antiderivative on cosecant, for instance, in this case. Um, this also imply that if I were to apply my antiderivative with respect to x here on cosecant, I would be able to obtain cotangent x plus a c there. Now I hope that result is clear. This is the same result that I obtained from equation number 2 here. All right. So I hope that is clear. All right. So in this case, I'm going to copy this one down here so that I can make use of this result shortly. Okay. Now I'm going to put this result that I need. So I know that by performing an antiderivative upon cosecant, I will be able to reach this conclusion here. Yeah. Okay, so these are the two results that I need to make use of before I start off with this reduction formula. Right? Okay, now the tips that you wanted to use in your exam would be how should I start up? So the starting strategy is very important. Now I'm going to show you my starting strategy in this case. I would actually start from n minus 2. All right. Now the main reason why I start off with n minus 2 is because I knew the result for my antiderivative for cosecant square. That is one of the motivations that I use to start up this integration here, right? And then don't forget, most of the reductions formula require the use of integration by parts. Okay, so we have done with the first steps, so we are ready to perform integration by parts here. Okay, by performing integration by parts, I'll do it separately at the side here so that you can see what is going on. Now, first of all, we will let u equal to something that is easier to differentiate. Okay, easier to differentiate. As you can see, it's easier to differentiate cosecant here, and then it's easier to integrate the cosecant square. All right. So, therefore, in this case, maybe you would like to represent your u to be something that is more or easier to differentiate. In this case, I wouldn't say that it's too easy, but it's a more direct way of assigning your u. Okay, now from here, your du dx would be n minus 2. Okay, it would be n minus 2 cosecant n minus 3, of course, x. Okay, done. And then after that, you're going to differentiate the cosecant. So this is where this first result come in. Become very handy here. Right? So by differentiating cosecant, we will get a negative cosecant x cotangent x. All right. So we get a negative cosecant and cotangent x. Right. Now by touching up a bit, so I can write this down as this. Now I know that there's a cosecant here that would further reduce this to 2, and then I still have my cotangent there. Okay, now that is my du dx, right? Now the second part of the integration by parts would be to let your dv dx equate to something that is easier to integrate. So in this case, we let our cosecant square. Right? And then we know that by integrating cosecant, we will end up with this negative cotangent x here. Right. Right, now these are the result that we need to process the integration by parts. All right, now I'm going to pause there for a while. Hopefully you get the idea how we set up the integration by parts here. Yeah. If you are ready, then we're going to substitute this into the formula for integration by parts. Now the formula for integration by parts would be uv minus of v du dx and then dx again, integration here. Right, now that's a formal formula for that. Now if you are okay with this, we can just substitute all the result that we have here. Now that will be based on this, it will be negative cosecant n minus 2 x cotangent x. All right, now that's u multiplied by v. And then after that, I need to subtract off with v. Okay, so v is still this, and then with my du dx. Okay, now you notice that both of these are negative, so they cancel off each other. I'll just write this down as this, and then we have this as cosecant cosecant n minus 2 x, and then cotangent square x dx. All right, now there you have it. This is the result of integration by parts. Okay, and then from here you notice that we have cotangent square x. Cotangent square x is given by this identity here. Right, now I'm going to rewrite this identity so that I can make use of that. So by rearranging this identity, I can actually write down this as cosecant square x minus 1. So I can substitute this into here. Okay, hopefully we can get something out of that. All right, now I'm going to write that down. We have cosecant there. Hold on, just let me touch up a bit. Okay, so from here I have cosecant n minus 2, and then cotangent square can be written as oops, I forgot my x. Can be written as cosecant square x minus 1 dx. Okay, now that's what I have currently, and then of course I can further simplify this. Okay, while you're working with this, you have to be a bit patient. So I think sometimes there's a key to solving most of the challenging mathematical problem, right? So from here we have n x dx, all right, and then we have another one which is n m minus 2 here, and then cosecant n minus 2 x dx. Okay, now that's the result that I have. I hope that is not too messy here. All right, and then from here onward, I can further simplify this to something like this. Okay, now you'll notice that in actually represent cosecant n dx here. So therefore, this one can be written as in. And then this part here, I can rewrite that in a shorter form, which is in minus 2. Okay, right now, and then there you have it. My current reductions formulas form at this point of time. Right now, next I'm going to further simplify this result number 3 here, so that I can reach this final conclusion. All right. Okay, I'm going to pause there for a while. Okay, and then I'm going to bring this result up so that I can show it to you how I'm going to um, finalize the proof. Okay, all right. So if you are okay with that, I'm going to erase off those results that we have used. We don't need anymore. So in this case, I'm going to erase off this. These are not the result that we need. This is where we are currently. So I'm going to copy this one down. This is the current result that we have obtained. Okay, so there is n minus 2x cotangent x minus n minus 2 in plus Okay, now that's the result that I am right now. And then I noticed that both sides have in, so you might want to combine them. Now combining them would yield this result, of course. Okay, and there you have it. And then of course, a bit of rearrangement. For instance, we might want to put a positive term in front. Okay, and then finally, we can conclude that in can be written as or can be given by this one here. And then there you have it. That is our final result here. Right. So I'm going to highlight this. This is our final result. Okay. Right. Okay. So I hope that is clear at this point. Right. Do check out the working there, and then make sure you understand how to apply integration by parts, and then make use of the trigonometry identity, and then start up with a proper approach, so that you can reach the conclusions that they wanted. Right? Okay. So I hope this will be useful in your learning. Okay. Until I see you again. Take care. And then don't forget, if you like what you are looking at, do subscribe and then press the notification bell so that you can receive the latest uploads. Yeah. Okay. And then if you have any other requests, do drop a comment through the channel or through under the videos there, so that I can attend to that. Right? Okay. Until I see you again. See you, everyone.